Hey guys, the welcome back to my channel. In this video we'll be doing the part 2 of free body diagrams. No, sorry, Lamis Theorem example questions. So from assignment question number 4 we'll be doing some problems. So the first question is that a wire rope is fixed at 2 points A and D as shown in figure. Two weights 20 kN and 30 kN are attached to it at B and C respectively. The weights rest with portions AB and BC inclined at right angles 30° and 50° respectively. To the verticals are shown in figure. Find the tension in the wire in the segments AB, BC and CD and also in the inclination of the segment CD to the vertical. Actually, I haven't drawn the uh, diagram for that, but you must be getting actually they're not we can itself draw the diagram from this, so pause this video and just draw the diagram. So I hope you have drawn the free body diagram. Then we just need to use the Lamis theorem. So 20 by 160 here is equal to AB by sine 50 is equal to BC by sine 150. Then you will get the value of 44.4795 and 29.238. And similarly you can do the case of this also, you will get the answer. Okay, now let us move to question number 5. A wire is fixed at 2 points A and D. Two weights 20 kN and 25 kN are separated at B and C respectively. When equilibrium is reached, it is found that the inclination of AB is 30 and that of CD is 60 to the vertical. Determine the tension in the segments AB, BC and CD of the rope and also the inclination of the BC to the vertical. So this is our diagram here. Okay, so here we have AB, then we have BC, then we have CD, 20 kilonewton here, 25 kilonewton here. Then if this is 30°, we know that this will be 30°. Then this whole will be equal to 210 minus theta, because if this is 30°, then we can just draw like this. Then this will become 90°. If it is 90°, then this part will be equal to what? It will be nothing but 60. Then if this is 60, then and this part is 90°, then we will get the total angle here to be 150°. And if this is 150° and this is theta, we know that 360 minus 150 minus theta is equal to 210 minus theta. That is just what we have drawn here. Now after drawing everything, then we will, so we'll be having something like this. If you're considering the case of this part, then we'll be having T2 here, and here we have 20 kilonewton. Okay, so we know that this angle is 210 minus theta. I'm drawing it slowly. So we will get something like this. From here we get that T1 by sine theta is equal to T2 by sine 150 is equal to 20 by sine 210 minus theta. So we will get something like that. From here the known values are sine 150. So from here we'll get the value of T2. Okay, so T2 will be equal to 20 sine 150 divided by sine 210 minus theta. And in the case of this one, in this angle also we'll just do it. So here we know that this part is 180 minus theta, this is 120, and this is 60 minus 60 plus theta. So we will have T3 by sine 180 minus theta by T2 by sine 120 by 25 by sine 60 plus theta. Now if we do all the calculations, we will get we can equate T2 of this and T2 of this part, and if we equate it this with these two, we will get the value of theta to be 54.79. If we get the value of theta, then it's simple, we will get the value of T1, and then also the T3 value also will be found. So we'll get the values T1, T2 and T3 as follows. Okay, now let us move to the sixth example. Two smooth cylinders, each of weight 100 Newton and radius 15 centimeter, are connected at their centers by a string AB of length 40 centimeter and rest upon a horizontal plane as shown in figure. The cylinders above them has a weight of 200 Newton and a radius of 15 centimeter. We need to find the force in the string AB. Where is the string AB? So this is the string AB. This is the string AB. Okay, so this is the string AB. We need to find the force in the string AB and the pressure produced in the floor at the points D. I think D is the spot and C is E is the spot. Okay, so this is our diagram here. Now considering the forces, we'll just draw the forces of each. So we'll be having reactive forces of C1 and C2. Then we'll have a weight of C, and here in the case of cylinder A, there will be reactive forces of A and this side, and we'll be having a tensile force. And the case of B also, there will be a reactive force like this and a downward force, which is the weight, and here like this also there will be a force, and actually there will be a reactive force also from the ground. Okay, so this is the number of forces acting in each. Now what we need to do is that resolve each of them to find the so we need to find the force in string AB. So I think this tensile force will be equal, so we just need to find tension. So uh, here this AC and BC is equal to 30 centimeter, AB is equal to 40 centimeter. These are the values which are already given. So if we are given the value of AC and also the value of AB, if AB is equal to 40 centimeter, we know that this part, if we are considering it to be a value of D, then we can say that sine theta is equal to 20 divided by 30. So we'll get theta value of 41.83. So this theta is this part. If we are getting this value, then we can find the angle of this part and angle of this part also. So if we get the angles, then the problem has become very simple now. Now we just need to take each one of them and use the Lamis theorem, and we can find the value of R1, R2, then the tensile forces and everything. So it's just that you can copy this if you want. Now let us move to the seventh question. Seventh question is a very complicated problem. It was previously asked in JE Advanced. So I want you to try it, understand it, then we will just do it. Okay. So three uniform homogeneous and smooth spheres A, B and C weighing 300 Newton, 600 Newton, 300 Newton respectively, and having diameters 800 mm, 1200 mm, 800 mm respectively are placed in a trench as shown in figure. We need to determine the reactions at the contact points P, Q, R and S. So in this case we just need to find the reactions which are happening. So what are the forces? what are the main forces happening in this case. So if we are just drawing the centers, I think these are the centers. Okay, now there will be a force like this here, a reactive force like this, and a reaction force downwards, and there will be a reaction from the wall this side and a reaction to this side. Okay, and here in this case there will be a reaction like this, then there will be a reaction like this, there will be a reaction like this, weight. Okay, so these are the forces. Now we need to take each one of them. Before that we need to find the angle also. We can find the angle because the radius of these cylinders are given. So from that we'll get the value of alpha to be 11.539. Then we will take each one of them, and we will take the force system of that, and we'll just equate it using Lamis theorem, and we'll get the value of P, R1, R2, and so on. Okay, we'll get the value of P, Q, R, and S. So that is all for this video. In the next video we'll be talking about coplanar non-concurrent forces, moment of force, and we'll be doing some examples also. Okay.